Hello, everybody, and welcome. Glad that you can all join us. We will begin very shortly. We're quite glad to have you all here in our Kipu Planqk webinar regarding serverless quantum computing. What's new? So we will start very shortly when Michael's presentation is ready. And we have an exciting hour ready for you. So the reason why we have called this webinar What's New is that this is, of course, not our first Kipu Planqk webinar. Indeed, the last time we had our Kipu Planqk webinar, we were looking at one of Kipu's newest algorithm, the DCQO implementation that was available on our Planqk platform. And today, we want to walk you through a little bit more along the lines of how you can interact with Planqk, not so much as a consumer of algorithms, but rather as using our platform for serverless quantum and what that all actually entails. So with this, we're going to start now. I think we haven't gotten many more people joining, and even if they are a bit late. So a very warm welcome. Thank you all for coming today. I'm very honored to greet you here. My name is David Niehaus. I'm head of commercialization here at Kipu Quantum in Berlin. And with me is my colleague, Dr. Michael Falkenthal, our head of platform. And we are currently going to, there was one thing wrong. So we want to show you a little bit, not only what Planqk can do for you from a developer perspective, but also looking at Planqk more from the lines of interacting with it, not so much through the website UI, which we have covered in the last webinar, but rather more interacting with Planqk from your development environment, which is how you're much more usual to interact with it. Of course, such a webinar cannot start without us giving a couple of introductory sentences and slides. Michael, if you could go to the next slide, please. Thank you. So you are joining a community of over 600 users that really range not only across the entire world, but also from academia over to industry and to governments that are using the Planqk platform. And of course, Planqk is available at a starting point for free, but it has several different offerings. And along those different offerings, there's, of course, the exclusive access to Kipu's algorithms, the most important aspect. But at the same time, we see a lot of developers interacting with the Planqk platform to benchmark their own algorithms against Kipu's algorithms, but also consume quantum resources through the Planqk platform in order to further theirs and our overall understanding of how to use quantum. So Planqk really acts as a marketplace, not only for algorithms, Kipu's as well as others, but also as a DevOps platform. DevOps platform for quantum, and this is what we call at Kipu QOps, Quantum DevOps. We are coming from the scientific side of things, so of course our Planqk platform also contains a community part where use case libraries are can be used publicly, demonstrators are available, and also knowledge about our algorithms can be used. This is particularly of interest, of course, for researchers, for research projects that want to disseminate their knowledge, but it's also a very valuable starting point for enterprises just entering the quantum era. They can use this as a starting point to understand how quantum can benefit them. Next slide, please. So there is, of course, the pay-per-use access to algorithms from Kipu. Of course, we have also published a couple of algorithms for free to play around with it. There is the hardware agnostic development and testing capabilities that Planqk offers. And of course, the aspect that we are going to focus on during today's webinar, which is really the quantum development tools that Kipu provides to you. Maybe as a very, very brief hint towards our next webinar, which will take place in April, we will be talking particularly about the context of workflows. So how can you combine algorithms from others, such as Kipu, with your own work and generate a new, more advantageous, more complete solution that can be used. Of course, this is all available there. We have great collaboration features to enable really projects that also cross organizational boundaries. And ultimately, the advantage of Planqk is also that by using Planqk, you benefit from a sort of obfuscation. But that will also be covered in another webinar. Next slide, please. Overall, just as a very last, second to last point, actually, of course, you're aware that you can access Planqk for free. There is a the registration simply available as a QR code at the end of this presentation that Michael and I are going to give you, which allows you to utilize the basic platform capabilities. You can have access to standard basic hardware, and then, of course, also basic hardware access. Now, for industrial and academic users that want to do more with the platform, there are 2 more tiers available. And if you have questions about that, please do not hesitate to reach out to us if you want to use more advanced hardware, if you want to use more advanced algorithms, and of course, also benefit from, for example, the collaboration features that I mentioned earlier. And now to the very last slide from my side. Just to give you an overview of our offering. Of course, you know that Kipu is a leader in quantum algorithms. And the question is, of course, how do these algorithms and this expertise now slots in with the overall Planqk platform? Now, we consider Planqk to be the baseline for all our additional expertise. So as you have just seen, our Kipu Quantum Pioneer program, the access to the platform is available at different tiers. And based on top of that, we have different services where we have created a mix and match system, how we call it, where we provide not only the standard algorithms available through the platform, but we can also work with others to customize those algorithms to base entire quantum solutions on it, or help you in through workshops to through use case preparations in order to further your quantum journey. There's really a whole lot of things to do, but since this is really more a webinar around how to use the Planqk platform, I'm going to stop right here. Just wanting to let you know that there's this range of possibilities to interact. Feel free to reach out. And with this, I now hand over to Michael for our very intensive demonstration and deep insight into the Planqk platform, how it works, what does it actually mean to do serverless quantum computing. Michael, over to you.
Yeah, David, many thanks for the nice introduction. So first of all, before I go into more details, I want to just ask you, when there are some questions, if there are some questions, please don't hesitate to ask them, either maybe via the chat function or also say raise your hands somehow. The problem at the moment is that since I'm sharing, I cannot see if somebody's going on in a chat or so. So I ask my colleagues please to have a look at it. And also to the audience, please, if some questions arise, don't hesitate. So this is also kind of an interactive thing. It must not be just a monologue from my side. However, to step into the whole serverless part. So the interesting thing is, so at Kipu, to be honest, like in our core tech, we develop quantum algorithms. Yeah, and therefore we are really also faced with the question. Today, of course, quantum algorithm development means typically, research on the one hand, and then deriving, say, algorithmic approaches from business problems in order to solve them, etc. And we are typically working in a so-called project-based revenue model. What we see here on the left side. Let me also use the laser pointer here, then I can see better. So this is the current situation that we are faced with in many different customer-based projects, right? But of course, what we are actually striving for is to reach out with our quantum algorithmic approaches to not just single customers, but to whole verticals and a multitude of customers. So therefore, automatically, if you reach this state of maturity with the quantum products, you have to ask yourself, how can I scale out the whole business actually, right? And also vice versa, if you are kind of a customer and you're just interested in consuming a quantum solution in order to improve, let's say, some of your whatever legacy IT systems in a way that is currently interactable with classical hardware and classical algorithms, you also have to ask yourself the question, how can I actually easily use or make use of quantum solutions? Yeah? And basically, as you will see at the end of the presentation, today, this is also not just a question about quantum algorithms in Greek letters, but it's simply also a question about integration. Let's say the IT stuff that we do for decades now, but this also applies to quantum, of course, right? And this is kind of the base or the starting situation that we are currently faced within Kipu on the one hand with our algorithmic approaches, but on the other hand also when we want to ship our actual algorithms as services, as API-based services to our customers. Yeah? Meaning we want to move from our project-based revenues that are quite nice today to a more scalable business model in the future, which we call quantum solutions as a service revenue driver, right? So how can we achieve this, or what kind of problems do we have to tackle for exactly solving this problem? So first of all, what we call this, our mission here, we call it frictionless quantum. What does frictionless actually mean? This means we identified, of course, in our, let's say, daily business that today quantum means typically that, let's say, some wise quantum physicists sit together and sketch and craft new algorithms, like say with some black magic in it, right? Of course, this kind of crafting IT solutions is not a very sustainable one. This moves, of course, the whole industry towards quantum advantage at the moment. So it's really research driven, of course, but it's not sustainable in order to really bring quantum solutions as hardened solutions into IT landscapes in businesses, right? And this is exactly what we want to tackle with the phrase frictionless quantum. Meaning, we want to really start at the story where we are today. Meaning, quantum physicists develop quantum code, right? They typically are not trained in, let's say, deploying systems to or code to production system, in being trained in monitoring those systems, being trained in, let's say, driving the systems and fixing bugs, etc. Things. So this is really something that comes to the table once you talk about quantum solutions that are really used in production use cases. And our approach with the Planqk platform here is to exactly help to raise, let's say, the initial quantum algorithms that we have today that in theory and in experiments work very, very well in tackling, let's say, real world problems already today. How we can use, let's say, DevOps principles that are well known from the IT world already in order to allow quantum developers, as we have them today, to raise their code to products that can be used in, or that can be integrated in legacy systems, so to say, into those systems where the business problems themselves actually reside. And to achieve that, our frictionless DevOps platform, so to say, allows quantum developers here. We call it also quantum developer community because it's not just Kipu, it's also, of course, others that play a role here. I have also a case, if we will have time at the end, I can also show a demo here with the Munich Quantum Toolkit, for example, which is integrated already nicely in the Planqk platform. Yeah, so we call here, we have a whole developer community, and we allow them to raise their quantum code, which currently resides on laptops and in some Git repositories, maybe all still in Jupyter notebooks, to quantum code that is, let's say, black boxed behind an API. Right, so we introduce an interface, a technical interface above the code, so that every system in the world, which also must not be, let's say, implemented in the typical languages like Python or so, can just integrate with quantum code as solutions, as API-based solutions. Yeah, and for this, to achieve this, we not only provide, let's say, development templates, in which I will go into detail in a couple of minutes, but also the capability to, if you base on those templates, you can quite easily deploy your code as APIs and automatically managed APIs to the Planqk platform, meaning they are available to whomever you want within minutes, instead of, let's say, developing a whole deployment and API management platform on your own, right? Of course, the platform itself also provides you usage metering, and if you want to monetize your services, meaning you really provide it into a marketplace, the platform itself already also provides you with a payment gateway and payment mediation between your customers and of course yourself. Yeah? So you don't have to develop this on your own. On the other hand, as a consumer of these kind of quantum solutions in the future, this also means everything is already in place, and quantum in the future means nothing else than just easily, let's say, consuming an API via a marketplace, via the Planqk marketplace, of course. So how can we achieve that something is then in the marketplace, of course? So what we call APIs, behind the APIs, of course, there are always implementations, and those implementations are so-called services, like sketched here on the upper right corner in this graphics. The interesting thing is we not only work on raising the actual, let's say, quantum code or algorithm code to APIs, but also on a technology stack to easily integrate those different kind of services, meaning that once you develop a kind of service that incorporates some, let's call it, mathematical solver to solve some intractable problem on a quantum device, at the end you always have to ask yourself, how can I integrate this actually into, how can I solve it a business problem with it, right? So at some point you require transformation from your business domain into the quantum domain, typically in some kind of a mathematical structure that then can be mapped on a quantum device and solved there. And this is exactly where our service and API approach go hand in hand, meaning we also develop a orchestration layer for services that you can, let's say, stitch the quantum solutions together with the necessary transformation code from your business domain. Okay, and this is actually also the important part when it comes to solving actual use cases, actual real business problems with some quantum algorithm. Of course, at the end, you also require access to quantum devices, and in this manner, the Planqk platform also acts as a let's say an access hub to different quantum devices. What we essentially do is with the Planqk platform, we integrate all the available quantum backends. Of course, in the future, there will follow more. I will show you later on. But the idea is, of course, to have an end-to-end platform that allows you to access multitude of quantum backends, not just quantum backends, but also simulators and emulators of future quantum solutions, especially also in the German ecosystem, where many new quantum devices are currently under development. And at the end, to integrate those access to quantum devices into the algorithms and the business applications that require them at the end to solve the business problems. So therefore, just to give you a brief overview again on what Planqk in total is, I will not go into details. I think we had several webinar already on other aspects, but Planqk is not just let's say is composed of different kind of modules. I would say on the one hand, as David already mentioned, we have a knowledge platform where especially researchers can interact with each other and especially also collaborate with each other to formulate new interesting algorithms or discussions on algorithms, etc. Important here in this knowledge-based platform stuff is it's not all about the community that is, let's say, open. It's also possible to use Planqk as a closed community, meaning you can open up closed spaces on the platform, which you can use, of course, to also share, let's say, more secret stuff, which must not be which must not go into the public, so to say. Yeah? So therefore, Planqk is always twofold. Of course, public version, but also you can use it in a more strict way to secure your data, right? And of course, the serverless platform, which we'll go into detail today. I also already sketched a quantum orchestration platform already in the slide before. We have the marketplace, and of course, in the future, new features will come. But today, especially those two parts will be tackled by. I will tackle them on a conceptual level. I have prepared some slides already that also give you a feeling how this really works when you develop with it. When you are interested in let's say real hands-on sessions, maybe to also play around with a specific use case of yours or so, please also get in touch with us. So we are happy to also schedule meetings afterwards with you so that you can get a better feeling when it comes to real hands-on sessions, right?
Michael?
Yes.
Micah, I quickly do an interruption here because we had an interesting question in the chat.
Of course.
Since the recorded, I will not say the name due to privacy reasons. The question was, how do you see the role of quantum computing evolving in industrial applications? And what challenges do you anticipate in making quantum algorithms more accessible and impactful for businesses? I think you and I share the answer to that. I'll do the first more commercial part, and then you do the more technical part. In answering your question, Michael will actually be talking about that a little bit more detail with regards to the technical implementations. But overall, it is our belief that algorithms developed by Kipu and others will become more used, of course. It will, however, not be exclusively used. And this is why I mentioned very earlier that our next webinar will be more around workflows, because we believe that quantum algorithms will strongly interact with classical algorithms or classical applications. And this is exactly why we feel the way we have structured Planqk, that the quantum algorithms become available through APIs, makes it easy to integrate them into existing systems, because quantum algorithms will not be replacing existing IT landscapes. They will become a meaningful building block of that. And that also brings us directly to the challenge, which is how can we adjust this classically trained knowledge of making a software available as a service through an API available to the quantum community. And this is why we consider Planqk to be a quantum DevOps platform, because it provides these capabilities in an automated way. So this is, I think, more from the top-down perspective, a first answer. And Michael, I hand now over to you because, of course, you're covering it much more on a technical level.
Of course, like I just can add here one technical aspect here. I think David already mentioned that. So there will be not a mode in terms of like you just have a quantum computer and then now you do an offload of your typical, let's say, business calculations to it. We always will end up in kind of what we call hybrid workflows, meaning you have to orchestrate actually classical processing. And not only classical processing in terms of CPUs, but also, let's say, offload of workloads on GPUs, which we see currently also with this agentic movement that we since a year now, so to say. And of course, then the QPUs, the quantum processors, will also play a role in this whole orchestration. And this is what we call in the future hybrid workflows. I will have on the very last slide a outlook on that. This will be covered in another seminar, but this is the technical answer to what role will quantum play in the overall, let's say, thing. It will play a role in the overall orchestration, technical orchestration to tackle yet intractable problems. Good. Then let's move ahead. So what I want to tackle today actually is exactly this kind of end-to-end example. Yeah? So when it comes to solving something with a quantum computer, at the end, of course, at the very beginning on the left side, you see at the end you need an algorithm somehow. You need something, an entity, an algorithm that makes use of quantum computers in order to make something that is yet intractable by classical hardware solvable, right? So this is why we have this code part here. I will go into details in a couple of seconds how we support exactly this. So this code part is especially meant for developers in the whole end-to-end tool chain, but not solely. This also is about easily deploying and creating larger experiments. So we also work together a lot with not just industry partners, but also academic partners, meaning it is not about solving, let's say, business problems like supply chain problems, but it is more about running really or developing really large experiments that deal with quantum chemistry simulations for just to give you one example, right? So we have some tools here in place that especially supports the coding part, meaning this kind of that you can develop this kind of hybrid access to classical and quantum hardware. The next step is the deployment step, meaning, of course, development takes place on your local machine. Often it's done in Jupyter notebooks still, especially when you try to fiddle around with some libraries and try things out. And especially if you're in the early stage of quantum, when really it comes to the learning part, what do we have to understand in order to transform a business problem into something that then can be solved by a quantum algorithm? Yeah, and especially this deployment part, which we support here as a subsequent step after the coding, makes it super easy for developers to deploy their code that yet resided on their local lab machines to a quite powerful serverless cloud environment, which is of course Planqk, to then also run not just, let's say, the dummy experiments on let's say the laptop hardware, but really scale up to nodes. At the moment we support nodes up to 200 classical cores, terabytes of RAM, even having GPUs attached to it, and of course in the whole system also having access to quantum computers to deploy and run, of course, then the whole stuff. When it comes to the run phase, if you really have your code in place and you have to deploy it, then of course you want to run your experiments or you want to test it. Yeah. For this, we support let's say a twofold approach. The one, of course, is the manual testing and manual running of stuff. This is especially tailored for running, let's say, experiments in the lab, so to say, the quantum chemistry case, for instance. This is something that is not triggered and integrated into, let's say, a business application, which triggers 10 calculations in a second. It's more a thing that you plan an experiment and then you trigger it manually, and then it runs for days or even weeks. Yeah, we have workloads that run even weeks, of course, right? And therefore, you can do it manually and controlled, even controlling the data that is fed in and controlling also the results that get out. But on the other hand, as we mentioned before, since we wrap everything with APIs, you can also easily integrate it into other systems, and then the systems themselves trigger those services, the process instances, so to say. Yeah, and at the end, depending on your perspective, of course, like for Kipu, it's an essential part to provide our algorithms, of course, on our marketplace, and we provide already the marketplace, which allows you today already to provide quantum solutions, or even, let's say, quantum inspired or classical or hybrid solutions, depending on what you developed, and adding a pricing model to it and providing it to the whole quantum community that was already, let's say, described by David. So currently we have more than 600 users on the platform from more than, I don't know, David, if I'm wrong, but more than 100 organizations, definitely maybe 150 already. I'm not sure at the moment, but
we recently knocked down the next milestone. More than 200 organizations are now registered on Planqk.
Great, nice. Even nice for me to hear that. Great. So here is really a benefit of the Planqk platform already. So we have a community on the platform, and if you deploy something on the platform, you reach out automatically to this community. So you gain visibility, right? And therefore we have already a marketplace there. So for the developers in the audience, I raised everything to a conceptual level. So also for the non-developers, don't be afraid. It will not get too technical, but I try to really cover out the most important aspects, how you as a developer, how the developers are boosted by the Planqk platform. Yeah. So first of all, when it comes to the coding phase, what we already support is we have a so-called CLI, called command line interface. A command line interface, you can just imagine you a developer sitting at the laptop and pulling up an development environment, and then they typically use this terminal stuff, these black windows where you can type in code or commands, so to say. And we for this behavior we have specifically tailored the Planqk CLI, meaning it helps you to scaffold new quantum projects. What does scaffold mean? Typically, it's quite cumbersome to stitch all, let's say, libraries and dependencies and that are required to solve a specific problem together, version it, etc., bringing up a whole project structure that just, let's say, it runs your stuff. And this is exactly what the Planqk CLI is intended for. You can use it as simple as that. You can, of course, you can install it, as I mentioned here already, with the first command, npm install, with a standard package manager. Just this one command, and everything is on the local machine. And then you can use the Planqk init command on your terminal. And this Planqk init command then makes use of so-called development templates that we developed on our own, but also that we have developed together with the community already. Important to know here is that Planqk was developed, or the core concepts of the Planqk platform were developed in the German Lighthouse project with a manifold of different parties involved, also from academia, etc. So there also was a quite lively community there who provided different kinds of development templates that tailor, let's say, these kind of project structures and required libraries, etc., already to specific use cases. I already mentioned one of them, the Munich Quantum Toolkit from the Munich Quantum Valley is, for instance, one of the templates that you can just use there out of the box. Just key in Planqk init, then you can select from the templates, and at the end you just hit enter, and then your whole project is scaffolded for you. The important stuff here is it's not just about the project structure, but you also can specify let's say the runtime parameters that have to be fulfilled by the platform if you want to run it. Meaning you can specify the number of CPUs that shall be used when you want to run this algorithm or this project, the amount of memory, if you want to attach a GPU on it, all these specifications when it for running the stuff can be also, let's say, the CLI supports you to specify those. They can of course be altered afterwards also, but it's super easy to exactly define an environment from the coding perspective, but also from a runtime perspective, which ends up then in a scaffolded project that you can just use and start developing. You don't have to bother with boilerplate stuff. Yeah. And of course, as I mentioned also, this is community driven, this is open. So if you have new ideas, reach out to us. Of course, you can also contribute for specific verticals, new development templates. So this is absolutely open approach. Yeah.
Michael?
So when you, yes.
Interruption. We have two questions.
Please. You have
one
to, because
is,
I don't see if somebody raises.
Yeah, that's why I'm doing it. One is we have one listener who already tried the Planqk CLI in the meantime and mentioned that Planqk init asks directly for a service name.
Exactly.
Can you elaborate maybe on that?
Absolutely. So the thing is, you can just, if you don't give a name on your own, we dice some funny names for you, so to say. What you can provide here is just key in a name, a meaningful name for your service, but because at the end, in the next step, you will see how you can deploy it. Yeah. This name will be the service name in your account on the platform itself. Okay, so if you call my super service and afterwards deploy it to the platform, it will appear there with the name my super service, so to say. Yeah, this is just that you can find your implementation or your service on the platform. And if you key in that, then you will also, the CLI will follow up with further questions, meaning, for instance, how many CPUs, which development template, which amount of RAM, etc., what I described before. And once you're done, everything is
that already covered the question. But Perfect. Prior to that, there were actually two questions where I do know the answer to. Okay. We had two prior questions. One is, say we have a patented algorithm. How's the NDA, data algorithm security handled, considering it will be deployed onto the Planqk server, and how does the pricing model work? I'll take that. Yeah. So with regards to your first question, with regards to the patented algorithm, so there are several ways of doing it. Of course, if you upload something that you have patented, or even if you do not necessarily have to patent it, it could also be a trade secret, right? By uploading it onto Planqk, it is, of course, in a secret container. So we as the Planqk operators cannot look into that container. The second aspect to that is also you can also decide to host it on your own service, but still make available through the Planqk marketplace. So this way you can be sure that the code itself never leaves your premises or your environment, whilst at the same time profiting from the Planqk marketplace. And that directly brings me to the actual pricing model. So we currently have pricing models that are based as margins on top of the hardware resources that you consume. This is constantly in flux. I think as an industry, we're currently at this very interesting stage of nobody yet knows how to actually price a quantum algorithm or an one-time shot of a quantum algorithm. So this is our first instance. We're currently trialing it out to see how it performs. And depending on those results, we will also add new features, new capabilities to Planqk to adapt those pricing models.
And also, maybe from my personal perspective, I'm doing cloud computing now for decades already, I can say. The choice here is really to go on for pay as you go, on demand pricing, exactly, also to lower the barriers for everybody. So in our perspective, it makes no sense to spend upfront a huge amount of money just to get access to something. Yeah, it's really based on, we want to warm the whole community, of course, and build the quantum community. And this is, I think, an important aspect. Of course, it's different when it comes to enterprise solutions. So David also mentioned that the platform itself can also be deployed on premises in enterprise if it is required. Then it's another model, of course. But for the SaaS version of the Planqk platform, it's for your entry, it's on demand pricing. And of course, if you get in touch with us, it might also be not the standard on demand pricing, but depending on your actual demand, it can be, of course, some negotiations. But this is, I can say that easily because they will be done by David. Good. David, further questions or?
No, we have for now provided hopefully all the answers to all the questions to all the participants, but I'm sure there will new come up once you go to the next section.
Okay, perfect. So to get back to the whole storyline, so imagine now we have scaffolded everything in terms of a coding project and also specified which classical resources are required when you want to run it. Of course, then the question occurs, how can you access different kinds of quantum backends via the Planqk platform? Because I mentioned already, Planqk also acts here as a hub for accessing different quantum backends. I brought here one example with the so-called Planqk Quantum SDK. With me here on the slide. Our intention here is really to not develop yet another software development toolkit to actually do what also Qiskit and the others that are already present in the industry do. So what we do, we extend, we base on the industry standards, and we extend them in a way that you just require one account on the Planqk platform, but with this one account, you can access all the quantum devices that are also available via AWS, via Azure, and even beyond that, even beyond those platforms, the big cloud vendors, we also work on direct contracts with different vendors already, right? But the core idea is really that you have this is now the example with Python, of course. Yeah, you have to install the so-called Planqk Quantum package, and this the Planqk Quantum package provides you in Python, of course, in this case, with so-called quantum provider that can be, for example, easily be used in Qiskit. So if you already coded something in Qiskit, it's super easy to use Planqk to get access to quantum backends. Just install the package and then import it, Planqk Quantum Provider here. And for all of you, as I mentioned, the coding part is for the coders. Of course, you import it here in Python, and then of course you can easily create a specific provider. And here you can of course add your access token that can authenticate your code with the Planqk platform. Meaning, with this, you then can for instance, with the next command provider backends, you can then look up to which quantum backends you already have access via the Planqk platform. Okay, and of course this applies to Qiskit. In this, we also have support for PennyLane already. We also have support for the AWS Bracket SDK. So the idea is here we don't want you to change your code just to use the Planqk platform. Yeah, the idea is don't change the code, not yet another SDK. Just use what you already have. And here's an example that with the provider you can, for instance, get access to the IonQ simulator, which is provided via Azure Cloud, or the QRA Aquila device, which is provided via AWS. So you already see in this example that it's super easy to in one program that you can access different kinds of quantum backends with just a single provider here. Yeah. Good. Maybe one additional thing. We have two access modes to Planqk. The one, if you sign up, you first of all have a personal account. Yeah, you can do it like really as a single person, but you can also create so-called organizations and then invite others into those organizations. And within those organizations, of course, you can also manage your budget, for instance, that is available to access quantum devices, etc. And this can also be handled in your code, of course. If you want to execute something with your personal account, you can just use a personal access token like here. But if you want to if you have a more sophisticated organization setup, you can also provide here another parameter, which is then the organization ID. I left it out here for simplicity, but then you can of course get also access in an organizational context to backends. Yeah. Good. Then we are through the coding. Now imagine we have finished our nice our code. now we want to deploy it somewhere. Somewhere means on the Planqk platform to run it afterwards with the specified resources. And it's as easy as you can see here. You just have to go into your project. Yeah, on the left-hand side, you open the terminal and you just key in Planqk up. And the Planqk up command does the rest for you, meaning it takes the whole code that you have provided here or developed here, ships it to the Planqk platform, builds a container, a Docker container for you, wraps it with an HTTP API, as mentioned before, with this APIfication stuff, and then places it as a service on the Planqk platform. Of course, as a private one. It's not public. Yeah? Public means only if you want to share something, you can put something in the marketplace. Then, of course, it's publicly available in the marketplace. But if you just normally interact with the platform, it's all private in your account. Nobody else will see it, right? Because there was the question before. So the Planqk up command, as depicted here, let's say puts everything on the Planqk platform, wraps everything, your code with an API, and then you can start using it. Yeah. So I think if the person who does the hands-on session, I think this should be also for every templates that we provide, you can also do easily the Planqk up stuff, and you end up then in your account with the service name you provided as the service. Yeah. Then when it comes to running those things, maybe first of all, let's say, why do we call it serverless? I mean, the whole talk is about serverless. First of all, yeah, serverless here in this aspect really means you don't have to bother with the actual hardware the system runs on. Yeah, you don't have to spin up a server. You don't have to manage the server. You don't have to install updates on the operating system, etc., etc. It's all transparent. Yeah, you can really speed up. You can really focus on your coding, on your value add, which is of course providing and developing quantum solutions. Yeah, not managing the hardware behind. This is all done, of course, by the Planqk platform. Yeah. And here important, now I go to the run section here. Important to understand here, let me please start here on the right side actually to follow the story. Managing the hardware for you means in this case that if your service is not used, you don't pay for some idle costs. Yeah? There's no server around that you have to pay for. You only pay for what is reduced in terms of the resources, as mentioned, a real pay-as-you-go model, on-demand model, right? This also means we have a scale-to-zero mechanism, and once some request to your service is triggered, then and only then the platform instantiates your code as a service instance, provisions it, and then automatically runs it. And afterwards, if the code is done, it also scales this down to zero again. So you end up again in a state where you don't have to pay for idle costs. Yeah. So this can significantly, of course, reduce, let's say, your infrastructure budget here. Yeah. And how can you now access those your functionality that you have provided via an API-based service? Of course, as I mentioned, you can, for testing purposes, the Planqk CLI also provides you a so-called run statement, and the run statement already triggers the service. In the service, in the templates that we have, you can already provide example input, so for testing purposes, also for manual experimental purposes, and then this data is used, fed in the API. The algorithm is then provisioned as a service on a compute node on the Planqk platform. It runs, of course, and then of course it feeds back the results, and you can poll for the results. Of course, it's not just about running stuff from the CLI. It's also, of course, about the integration. Yeah, and for instance, researchers often work in Jupyter notebooks, so it's absolutely not a problem at all. We also have a special SDK here. I will not go into details on this today, but there is also an SDK that you can use that you easily just trigger executions of your services and then get back the results. And this can easily be used, for instance, in Jupyter notebooks or in any kind of other program. Of course, in the quantum world, we are currently still kind of we stick a lot to the Python programming language, but we are not bound to the Python programming language in Planqk. You can also use any other language you use. So recently we have new experiments going on with the Julia language for some specific algorithms and benchmarks, and also for example, from Julia language, it's super easy to trigger this remote functionality on Planqk, because with this API approach we lift the whole access aspect to the algorithms to an HTTP protocol level, right? So from every programming language where you can send HTTP requests, you can of course then integrate quantum solutions into those systems. Yeah. And this is basically also, let's say, the overall idea to be able to create this kind of building blocks based on APIs, based on standard protocols, HTTP in this case, which are then composable to overall solutions afterwards, and integratable, of course, in legacy systems also. So, to give you a bit of an outlook already, the next backend integrations that will follow. So on the one hand, I take this snapshot an hour ago. So this is these are our currently integrated backends. You see already some stem from Amazon Bracket, others from Azure, and we have also two special cases, and these are the IBM systems and the D-Wave systems. So currently we do not have contracts with those players, but what we also developed is a bring your own access token concept. Meaning, if you have already access tokens to IBM systems via your IBM Cloud or IBM Quantum program, something like that, yeah, you can take the access tokens that you have, put it in your account, your personal account, as a secret on the Planqk platform, and then still you can develop this kind of solutions, which has then access to IBM Quantum packets in this case. But this, to distinguish it from the rest of the platform, this is then done via your personal access token. So not fully managed via the Planqk platform. And the same applies to D-Wave. Yeah. I'm not sure, David, if you want to share also some possibilities to do projects to get access to those devices together with us. But from a technical perspective and a development perspective per se, technically it's possible with own tokens where not Planqk manages the access to those backends. So what will be available next? It will be, I think, in a week, I guess, end of next week, we will also have the Rigetti Anka 3 system available on the Planqk platform for your access. And we also will get the Quantinum H1 system with full access, right, with the SDK that I've shown before. So in roughly 1.5 weeks, you will also have access to those two devices. Plus, we also want to support more simulators, because we are still in the early development phase of quantum algorithms, and therefore we see the value of course, simulators. And luckily, this is why I put this also in bold letters. Yesterday, our friends from QPerfect provided or published their Mimic simulator also as a service in the marketplace. So until now, you can already also access their super powerful simulator via an API via the Planqk platform. And similar to this, we also work together currently with Qt to also provide their simulator on the Planqk platform. Yeah, you see, we want to have Planqk in the future also kind of as an integration hub where you can access all the relevant stuff that's going on in the quantum field. Yeah. And finally, as kind of an outlook also for next webinar and the future, I already teased that it's not just about singular quantum algorithms, but as whole quantum solutions that essentially then solve business problems. And this is exactly what we are also striving for. Yeah. On the right-hand side, you already see a sketch of the already available Kipu algorithms on the platform. Currently, these are really the free versions of them. But of course, we have also, let's say, business versions ready, and we'll also launch them with pricing models in the near future. And on the left-hand side, you see also this concept of what would we call a workflow or on orchestration. So here, just an example. If you want to use some Kipu algorithm to solve some business problem, of course, the Kipu algorithm at first doesn't understand some business domain. Yeah. Therefore, we always have to come up with some, I call it mapping in this case, mapping business problem to Kipu algorithm. Yeah, so this is the translation from the business domain to math that I mentioned before. And of course, this is a simplified example here, but especially this is also then supported in the near future with this orchestration capability, meaning you can, with the functionality that I've shown you today, you can easily develop these building blocks, as I mentioned, as I call them, your algorithms, but also, let's say, mapping logic, etc. You can provide them and deploy them on the platform as APIs, and then you can imagine, like, you can really drag and drop them on a canvas, connect them with arrows, with a control flow, and then you can integrate those building blocks into overall solutions to solve business problems at the end. So therefore, stay tuned. Also, the Kipu algorithms will be present on the Planqk platform in the near future in business version, enterprise versions, which you can then easily use really to solve your business problems.
Yeah. Yes.
Finally,
thank you, Michael. So exactly. So great teaser for our next webinar. Thank you for that. We only have about 1 more minute remaining. So you have our email addresses here. Again, use the QR code in order to sign up for Planqk, to play around with it. And if you have any questions, ideas, how you want to try it out, just write us an email. We're happy to work with you to see how the platform and the algorithms can solve use cases for you. If there are no further questions in the chat, let me just quickly check. Nope, no further questions. Then thank you very much for joining this afternoon. It was great to have you. Thank you for all the questions. And see you around at the next Planqk webinar or in an in-person meeting or a virtual meeting very soon. So much from our side. Have a great day and talk to you soon. Bye-bye.